Welcome to the Stormsurf Video Surf Forecast for the week starting Sunday, October 27th. I'm Mark Sponsler, and I'm your host for tonight's presentation. We'll be talking about jet stream level winds, surface level pressure, significant wave heights, and all the things that go into making surf in the North Pacific. Let's get to work. First up, we're taking a look at significant wave heights for the North Pacific Ocean. We see remnants of a good solid gale that developed over the North Dateline region and is pushing off to the east while fading. Seas 23 feet over a pretty good area, aimed directly at Hawaii, less so at the U.S. West Coast. Also, southerly fetch associated with the same gale, pushing into Alaska, doing nothing of real interest. And then winds, strong winds, up to 40 miles an hour sustained off of Cape Mendocino this morning, produced wind swell down into North and Central California. That fetch and associated seas are still present off the California coast, but they're starting to fade. As usual, we start looking at jet stream level winds. These winds up about 30,000 feet help to support the formation of gales. When those gales form, help direct their track. We're looking for a trough, and we see a pretty good example of one right here. That is a dip in the jet stream going to the south, and then, of course, back to the north. That helps create a counterclockwise flow in the atmosphere, aloft and down at the surface, and that is the hallmark of low pressure in the northern hemisphere. And, of course, low pressure generates wind. Winds generate seas. Seas, as they radiate away from the fetch area, turn into swell, and swell, when it hits your beach, produces surf. So, we have a decent, not great, but a decent flow pushing off Japan with winds, about 110 knots. That's not particularly strong, but about normal. Falling into this trough here over the North Dateline region, which has been producing swell and seas. And then the other noticeable issue here is this giant ridge, right? Pushing well to the north. Now, a trough generates low pressure, a ridge creates a clockwise flow, and that is the hallmark of high pressure. And certainly we have a lot of high pressure occurring in the eastern Gulf of Alaska right now, and that is also contributing to the situation. Notice there's another trough right here off in Northern California inland. So that's low pressure inland, strong high pressure in the Gulf. When these two systems, competing systems, get close together, that creates wind, and that's what's contributing to the strong, we'll call them north-northeast winds, and what has produced some wind swell, and also feeding fires and a rather smoky situation, at least in Northern California this evening. Let's put this into motion. As we move into Monday, the trough in the Gulf, or in the northwestern Gulf, starts fading out. High pressure holds over the eastern Gulf. Now notice we still have a pretty decent flow here as we get into Tuesday night, 140 knot winds pushing off Japan. Not super well organized, not super strong, and you almost get the sense that it's split inland over like China and barely coming together over in the western Pacific. The trough continues, but it's just weak, not being fed by, it's almost like a double trough, like here's the northern branch of the jet, here's the southern branch. They're kind of almost merging, kind of almost feeding a trough, but not really. And then they split again. You get this split jet stream flow and high pressure continuing we're into Friday now. So you get, a little bit of support for gale development Friday night into Saturday here, but nothing super well organized. And then winds just kind of weak. I mean, most of this is likely attributable to the inactive phase of the MJO, and we'll get to that in a little bit. Sunday, the trough pinches off. Again, high pressure, just bulletproof over the eastern Gulf of Alaska. And there we are, 180 hours out. And really, let's go look where we are today. Not really a whole lot of a change. Yeah, the jet moving a little bit further south. The ridge holding, maybe moving a little bit to the east, and some sort of trough-like structure here. But it's sort of like this standing wave pattern in the upper atmosphere, and that pretty much speaks to what's going to go on down at the surface for the next week as well. But let's go take a look at the charts and see if that is, in fact, what's going to happen. So here we are, surface level pressure, surface level winds, as expected. There is our gale, or what was a gale, you have to have 35 knot sustained winds. So yeah, there are winds, they're all up in the Bering Sea, but in the greater North Pacific, we're down to 30-knot winds here. The gale is fading out. We also see high pressure, 1036 millibar high in the northeastern Gulf of Alaska, and then the remnants of what was strong winds off of Northern California this morning down to a little pocket of 30, maybe 25, 30 knot winds there. All right, let's put this into motion. As you see, everything kind of fades out as we get into Monday and Tuesday. Now, another low tries to organize on Tuesday. The fetch, this is the strongest fetch, 35 to 40 knot winds, but they're all aimed north at Alaska. Tiny area of 30 knot winds here. There we go. It tries to get organized on Wednesday. This is actually the best we've seen it look so far in all the model runs for the past 5 days. Little area of 40 knot winds targeting Hawaii, going down to 35 and 30 knots as we get into Wednesday night and Thursday. And it, too, lifts to the north. Remember, the jet is just pushing up this way, ridging hard. So the low-pressure systems are going to continue to follow where the jet leads. It doesn't work the other way around, unfortunately. High pressure holding as we get into Saturday. Another little cutoff low here in the Gulf on Saturday night into Sunday, managing only to produce 30-knot winds and lifting, not lifting too bad to the north. And there we are 180 hours out, so not a whole lot to look forward to here. Let's go take a look at the wave models, see what the effect of these winds are on the ocean surface. So here we are, significant wave heights for the North Pacific Ocean, but we're going back to Wednesday night of the previous week. This was a typhoon, Typhoon Neoguri, now caught by the jet stream. It was heading, recurving off to the northeast, and you'll see here what the effects are of that as it tapped jet stream level winds on Thursday. Seas were up to, 34 feet, quickly building to, here we go, max seas over the area, 46 feet, and continuing at 46 feet on Thursday night, down to 43 feet Friday AM, fading from there. But then a secondary fetch developed here with 37-foot seas aimed south at Hawaii, and that fading too, but still aimed well at Hawaii. We had a little dropout in the models here, and then as of Sunday morning, seas were down to 26 feet, and there we go, and that's where we are right now. Now, we're going to go back and take a little look here. Now, the point being, when this system supercharged, all the fetch was aimed off to the east at the U.S. West Coast, but it was a very small fetch area, and it didn't last very long, so you wouldn't expect that there's going to be large surf pushing into California from this portion of the storm. I mean, it was pretty good. Maybe we'll do better than what the model suggested. Then the second half of this system was all aimed southeast at Hawaii, and almost none of it at California. So it's basically two storms in one pushing east, one pushing south. At least everybody's going to get a little piece of the action. And then going forward, well, as we move into Monday, everything fades out. Much quieter pattern, little low. We saw that on the charts, trying to develop in the Gulf on Wednesday. What do we get out of it? 21-foot seas over a tiny area, so maybe some small 13-second period swell pushing into the U.S. West Coast. And maybe somewhere around next weekend. Now, this is probably likely to occur. It's within the 4-day window. Then after that, things quiet down a little bit. Another system, cutoff low, tries to organize here on Sunday. Seas get to 16 feet. That's good for maybe wind swell. It would be that maybe 9-10 second wind swell for Hawaii at best. And then that's it. So a sudden flurry of activity, and now back into the doldrums. Not what we're looking for. Also, in the southern hemi, we're not even going to show the chart. There's just literally nothing going on down there. A couple of small little systems, maybe targeting Peru, but nothing up into the North Pacific with a period of, we'll say, 15, 16 seconds or greater. So not much there. The season is winding down. So next up is the wind swell forecast. We're actually going back in time just to Friday night. We're looking specifically at this area off Cape Mendocino. Notice high pressure was 1038 millibars. That's very strong. And low pressure was building inland associated with the trough there, and sure enough, you see winds 35 knots off of Cape Mendocino. This was building through the day Saturday evening to 40 knots over a little area, and then starting to fade on Sunday. So really not as strong as what the model had shown even 12 hours earlier. At one point, it showed, here we go, right here, for Sunday morning, it had 35 to 40 knot winds over a broad area right off of Cape Mendocino. It didn't develop as strong as that, but still a strong northeast flow, mainly not even quite offshore anywhere in the Bay Area except first light on Sunday. All right, let's go take a look at the forecast now. So here we are, current and moving into this evening. Again, northeast fetch continuing, wind swell. Monday morning starting to fade. Notice winds down to 20, barely 25 knots, and almost aimed more northeast than north. So lower odds of wind swell making it down into California. Nothing for Hawaii. No significant area of 15 knot or greater east winds. Then we get into Tuesday. Again, the high starts breaking down, 1030 millibar, but we know that that's probably not going to be the case for long, because the ridge holds over the eastern Gulf. Anyway, 20-knot winds continuing, wind swell, small wind swell down in California. Local winds looking better as we get into Wednesday. Still nothing for Hawaii in terms of wind swell. Thursday, it looks like even the wind swell fades out, a rather light wind pattern everywhere. And high pressure, 1030 millibars, holding solid, waiting for some change in the jet to occur, and that doesn't look likely. Not even wind swell. Then as we get into next weekend, low pressure building off the coast here, but mainly targeting Hawaii, and that is at about midday Sunday, and then Sunday night. Still no wind swell for either Hawaii or California. Not really unexpected given the time of year. I mean, typically this is where you'd want to be seeing winter gales start to wind up. You'd want to see real long period swell evolving, but that is not happening. We know why. We're going to talk about that in just a second. Let's go take a quick look at precipitation, but that's purely a perfunctory view at best. So looking for precipitation, anything that's blue. In fact, here we'll scroll down. Let's see. That's the rain scale. This is the snow scale. We're looking mainly just for the area right around California here, and with high pressure locked in, working its way into the Four Corners region, there's no real expectation we're going to see anything. You see it. It's just like a dome. There's precipitation working around it, but cannot penetrate the center of the dome here. So you'll just roll this out. We're into Thursday, Friday. Right up here's the dates if you didn't know. And you see just nothing going on. We'll go right on out to Sunday. There we go. 180 hours. All activity being shunted up into not even British Columbia, up into central Canada, pushing Alaska, and that's it. Until the pattern changes significantly. And again, we think this is all attributable to the MJO. You wonder why we spend so much time looking at the MJO and studying it. It's because it dictates the macro level pattern for the North Pacific on a 30, 40-day period. So if you follow the MJO, you kind of got a good sense of what's coming for the next 30 to 40 days. And with that, let's go take a look. Here we go. Long-term outlook. We're going to talk, of course, about the MJO and the El Nino Southern Oscillation, short for El Nino or La Nina. So first up, the MJO. We first look at winds across the equator. This is the equator, that line right there. This is the East Pacific here, West Pacific here, date line right there. And the area that we're most interested in is what we call the Kelvin Wave generation area. Fancy words for the far West Pacific, but specifically from 170 west, 5 degrees north and south of the equator, the whole way over to 135 east, again, and then 5 degrees north. So this box right in here. So this is actual winds from the TAA buoy array, series of buoys strung across the equator used for monitoring El Nino. This is 5-day average winds, but that gives you a pretty good sense of what takes the noise out of it, gives you a sense of what's going on in regards to the MJO. So the MJO has 2 phases, active and inactive. When it's in the active state, and each of those phases lasts about 30, 40 days. It takes about that long the MJO travels from west to east, the whole way around the planet, but it takes about 30 to 40 days to make its trek across the Pacific. And when in the active state, and specifically in the far west Pacific, that suppresses trade winds, it supports precipitation, it imparts energy to the jet stream, which in turn feeds the storm track, which in turn creates storms, which creates surf. You know the drill, right? Okay? When in the inactive state, it does the exact opposite. It sets up like high-pressure, dry conditions, no precipitation, no energy import into the jet, and the jet kind of drifts off to the north. It splits. It does weird things, sort of like what is happening exactly today. So, right now, winds over the Pacific, we're just looking at the arrows, pretty strong out of the east over the eastern Pacific, also pretty strong over the central, and solidly from the east over the Kelvin Wave generation area. But it's not the actual winds, it's the difference, because winds, they blow on average at different speeds at different times of the year. So if you know what they normally are, and then you basically take this and subtract it from the normal, you find out what the difference is. That's what they call anomalies. Differences from normal for this time of year. And what you end up with, you look for the arrows here and you go, well, yeah, these winds are blowing pretty hard out of the east, but you look at anything going on here, they're a little bit stronger than normal over here in the far east Pacific. But over in this area, pretty much neutral. In the central Pacific, pretty much neutral. And in the Kelvin Wave generation area, a little bit out of the east, but not super strong. So this is not as bad as it looks, which is good news. Next up, we look at the forecast. Wind anomalies, 850 millibars zonal wind anomalies. Okay, that's fancy words for saying differences from normal in winds up at about 4,700 feet, which is a good proxy for what's going on down at the surface. They don't really do it down at the surface because there's a lot of noise. It's, it's more standard to do it 850 millibars. The winds are a little bit more steady. There's not any obstruction or anything. And this is for the whole planet now. So how do you read this? Okay, right up the center of the chart, 180 west. That is the date line, right? So the Pacific goes from about 135 east, so from about here over to about 80 west here. Okay, that's the whole Pacific. But the Kelvin Wave generation area from 135 east the whole way up the chart to about 170 west. So you just look down this chart back in early October, you see we had some westerly anomalies. The yellows are westerly anomalies. This is the fading end of, we'll call it the active phase of the MJO. And then the blues are easterly anomalies, and you see easterly anomalies encroached into the Kelvin Wave generation area and filled it back starting October 19th or 20th or so. And if anything, they're getting bigger in coverage, making it the whole way to California now, and no sign of westerly anomalies, the yellows or the reds, in the Kelvin Wave generation area. Clearly a sign of the inactive phase of the MJO. And then what's even more interesting, you see this here, just a giant, solid, rock-solid wall of raging easterly anomalies in the Indian Ocean at 180 east. So typically, you would see maybe something like this, and then you'd see strong westerly anomalies over here if you were in El Nino, but we're not. We're not sure exactly what's going on, but it seems like it's a long ways from El Nino. We're not sure that officially we're not in La Nina, but it sort of smells like it's trying to get organized. Let's go look a little further out. So now we can look 2 weeks out. These are outgoing long wave radiation. Where is it? Right there. Outgoing long wave radiation projections. Another component of the MJO. Okay? Blues are areas negative anomalies, that means more clouds. That's the active phase of the MJO. The yellows are positive anomalies, meaning more sunlight than normal, meaning the inactive phase of the MJO. And of course, there's Australia, there's New Guinea, there's the Philippines, South America. You get the deal. And 4 panels, each in about 5-day increments. So, inactive phase of the MJO, today, the statistic model suggesting, well, that's in 5 days that's supposed to fade out, and the active phase of the MJO is a weak version of it, supposed to make it into the West Pacific and then kind of fade a little bit 2 weeks out from now. That's not horrible. We go look at the dynamic model, and it says inactive phase fading, but no active phase, just a dead neutral pattern. But you know what? Either of these outcomes a week from now suggests the inactive phase, at least the worst of it, is supposed to be over. All right, let's dig a little deeper. Next up, phase diagram charts. So what is this? This is all about where the core of the active phase of the MJO is and how strong is it. All right, so how do you read this? This circle, consider that you're looking down on the North Pole, from up above our planet, down on the North Pole, and the MJO moves on the equator from west to east, over the Indian Ocean, over the Maritime Continent, across the West Pacific, over the East Pacific, under the United States on the equator, across the Atlantic, and then over North Africa, back to the Indian Ocean. The heavy dot, where is the heavy dot? Right there. That's where the active phase of the MJO is. And the further it is away from the circle, the stronger it is. So, a very, very weak active phase of the MJO centered smack in the middle of the Indian Ocean and doing nothing. Here are the three members, the three forecast tracks for the next 2 weeks. Basically, they're saying, yes, it's supposed to meander its way into the West Pacific, but be very weak. That's kind of what we saw. And this is per the statistic model. So this is what we saw in the previous charts. And the dynamic model, the GEFS model, saying the same thing. The active phase, making it into the West Pacific maybe a week and a half from now, but just incredible. As weak could be, right? So, no real hope. You really want a strong pulse of the active phase of the MJO to, one, help feed the jet stream. And if you get multiples of them, that's how you get El Nino. But all this is starting to smell, we've been talking about this before, smelling like La Nina, just a very weak pattern in the MJO. And if there is an MJO, it tends to favor the inactive phase. And when the active phase finally shows up, it's like half as strong as whatever the previous active phase was. Those are all symptoms of La Nina. Now here's the upper level model, okay? What are we looking at? A bunch of different panels here, but they're all the same. South America there. Central America there, New Guinea. This is the equator, right there. The date line, roughly right around there. There's Australia. You get the picture. Kelvin Wave generation area, right in there. If you see greens, that's areas favorable for precipitation. If you see oranges, areas not favorable for precipitation. You're going, well, wait, I thought we're in the inactive phase of the MJO. Well, the upper atmosphere is the leader, right? It leads by about a week on this chart. So this is showing the inactive phase. It's showing the 27th of October, but what happens in the upper atmosphere, it takes like a week for the lower atmosphere, to sort of like come behind. So this is a leading forecast chart. It's suggesting the inactive phase pushing into Central America, and the active phase, very weak like we talked about before, meandering its way across the Pacific in November into, about mid-November, the 21st, and then out. And then here comes another very weak inactive phase behind that. It sweeps through the Pacific, does its cycle into the first week of December, and then an even weaker active phase follows behind that. So no clear signs of any strong active phase, and if anything, you can sense the inactive phase is stronger in all these charts as we go through them than any active phase. The 1 month 850 millibar zonal wind anomaly forecast, another way of looking at the MJO. So here's where we are today. This is again the whole planet on one chart. Kelvin wave generation area from about here to here on the chart, going down or going up. Okay, so what we see right now, the blues, these are those easterly anomalies. This is the beginning of the inactive phase that started in mid-October. We're pretty much in the peak of it. It's supposed to fade for maybe a week and then redevelop again strong. So this whole thing here is pretty much the inactive phase from, let's say the 15th of October into almost Thanksgiving, according to this. Again, strong east anomalies in the Indian Ocean. And you look up here, here was our last active phase, the whole October, September, to the end of September. So that's the end of the active phase. Inactive phase in control now, and maybe for a bit longer. And then finally, the 3-month CFS model. Again, 850 millibar zonal wind anomalies, but it's flipped. The forecast is on the top, the past performance is on the bottom. Kelvin wave generation area between these two tick marks going up. So right here. So here's where we are today. Easterly anomalies. You can't make it out as clearly here, but this looks like the inactive phase here. So let's just overlay the MJO. Yeah, there we go. Right there. Okay, inactive phase, easterly anomalies to continue in some form into about mid-November. And then here we go. This is actually a better, stronger looking active phase than what we saw even yesterday. Still not strong, very weak. But active phase from a little bit before Thanksgiving the whole way through to Christmas or so. And then another weak inactive phase after that. Still with westerly anomalies in the Kelvin wave generation area. And then again giving way to a very weak active phase. So just a weak MJO pattern forecast for the next 3 months. Let's overlay the low pass filter. Here we go. So this one was showing stronger maybe last week, certainly the week before that. Currently 2 contour lines. This is a low pressure bias, the solid contour centered right over the date line. So one would say, God, this almost looks like El Nino. But it's not. It's not strong enough. You need at least 3 contour lines and maybe more. But generally, this is saying that, well, you're not in La Nina. You're just kind of in ENSO neutral, okay? Especially when you have low pressure basically filling the whole Pacific, from a very high level perspective. And here is what would be construed to be high pressure bias in the Indian Ocean. No surprise, and that's what's feeding all those strong easterly anomalies there. So this is no big change from what we've been talking about. So the thought is, for most of the winter, we'll be in some sort of not El Nino, not La Nina, just kind of neutral pattern. MJO looking to be pretty weak. Not a lot of energy in the atmosphere. I mean, functionally, it almost smells like La Nina, but it's not, and we'll get into that more right now. So now we transition from talking about the MJO to talking about El Nino, La Nina. So yes, Kelvin waves are a component. The active phase of the MJO is a component of El Nino, but really it's all about sea surface temperatures and winds on the surface of the ocean. All right, so let's look at subsurface temperatures, right? This is the West Pacific here. This is the East Pacific here. This is data from the TAO buoy array, series of buoys strung across the equator. You've heard the drill. These are the anchor lines on those buoys. The X's are the sensors on those anchor lines. Then you use a model to connect all the data and fill in the gaps. And what you end up seeing is warm water in the West Pacific, 30, actually look at this, a small area of 31 degrees Celsius. That's pretty warm. Temperatures in the far West Pacific, the 28 degree isotherm at 180, that's about steady. The 30 degree isotherm, the 29 degree isotherm to 165 west, that's about steady. The 28 degree isotherm to 155 west, that's been about steady too. The 24 degree isotherm, it's been toggling somewhere between 120 and 105, suggesting maybe there's some warm water pushing east. Let's go look at anomalies. Differences from normal for this time of year. This is what really matters. So we have warmer than normal water. Kelvin wave was sort of here. It's bleeding off to the east. This looks like the peak of it almost. Look at that. One little dash, maybe 3 degree anomalies here at, what is that? About 120 west would be right there. That's due south of Southern California on the equator only. Right? So when you have a strong active phase of the MJO, it creates westerly anomalies. It takes this warm water here and starts pushing it to the east, but not on the surface, under the ocean, under the equator. It takes 3 months, forms like a ball of warm water, just like that, makes it to the East Pacific, and then it erupts on the ocean surface, creates a warm slick. If you have multiple successive active phases of the MJO, and multiple Kelvin waves, you get a big ball of warm water that starts erupting on the ocean surface here, gets caught by the trades, and that's the hallmark of El Nino. But if you get you can get cold water showing up here, and we saw 3 months of that earlier this summer. Just iceberg cold, 4-degree below normal pocket here. It certainly smelled like La Nina was organizing, and it was bleeding off to the surface, making ocean temperatures, surface temperatures cooler than normal over here. But magically, this Kelvin wave all of a sudden woke up, decided to wash its way through, and kind of cut the legs out of that. But here we see this kind of cool pool thing starting to show up again. Not certain if this means anything yet. It's too early. But if we see this starting to get cooler and deeper, and one would think it actually would be. Here's the point being. The inactive phase of the MJO is in control. We have easterly anomalies in the West Pacific. That would provide the opportunity for cool water to materialize. Now, we have a blocking Kelvin wave in effect right now, but if we don't have any strong active phases of the MJO queued up behind it, we don't get any westerly anomalies, and the inactive phases are stronger comparatively to the active phases, the suspicion is we're going to end up with a cool pocket here. We're going to get cold upwelling, and we'll be right back where we were back in June, July, August timeframe, which again smells like La Nina. A different modeled version of the same data shows the Kelvin wave. This Kelvin wave number 5, much more pronounced. What is that? 1, 2, 3, we'll say 4 contours. 1, 2, 3, 4. 2 to 3 degree anomalies, maybe more here. This Kelvin wave number 5, working its way across the Pacific. The last little bit of cool water here, getting ready to bleed up to the surface and be out of there off of Peru and Ecuador. But then here's that cool pocket thing starting to develop behind. Not sure what or if that is anything. Now, this model runs about a week behind the previous one, but still, it's painting the same picture. Sea level anomalies. So what's this? Okay, well, there is South America, there's Central America, there's New Guinea, Australia. Dateline right there, equator right there. What we're interested in is just 5 degrees north and south of the equator right here. So Kelvin wave generation area right here. If you get active phase of the MJO, westerly winds, we'll take warm water from here, push it under the ocean surface the whole way over to here. There's the Galapagos Island. Here's Ecuador, and create a warm slick over here. Now, what is this? Is sea level anomalies, not temperatures. So how do you see warm water at depth? Well, you got the TAO buoy array. Another way to do it is via satellite. Now, it doesn't actually look at the temperatures 150 meters down in the ocean. What it does is look for a bump on the ocean surface. So this is from Jason 3 satellite data. You strip out all the swell, the wind waves, the tides, and you see here, this is a 5-centimeter bump. That's not very big. What, something like that? Maybe not even that big of a bump on the ocean surface. Okay, but what that means is warm water at depth, it expands. Cold water contracts, right? So if you have warm water at depth down 150 meters, it expands, creates a bump on the ocean surface. That's what we're seeing here, and that's what we're seeing here. Now, this all was one big interconnected pool last week. Now the leading edge of it is pushing off here to the east, almost to the Galapagos Islands. This would be the leading edge of Kelvin wave number 5. And then there's just some residual lingering warm water here in the West Pacific. So this basically corroborates what we saw in the previous images. Upper ocean heat anomalies, upper 300 meters of the ocean. This is West Pacific here. This is the East Pacific here. You basically can watch Kelvin waves, and they're very slow moving. They take, 3 to 4 months to make it their way across the Pacific. So here is Kelvin wave number 3 last year in November. It actually started like October, and it never fully made its impact into Ecuador. It wrapped up somewhere in the mid-January time frame. Then Kelvin wave number 4, same deal, started right in here, westerly anomalies in January, made its way across the Pacific, wrapped up sometime in May. That was 5 months to do the whole cycle, right? Then we had 2 Kelvin waves. I don't even know that we call them Kelvin waves. They were just stationary. There were some westerly anomalies associated with the active phase of the MJO, but they just hung here. And here is that cool pool we were talking about in May, June, July, into August, and even September. And then Kelvin wave number 5 arrived, starting in late August, September. Good active phase of the MJO, a bunch of westerly anomalies, and here is the warm water from that actually making good headway to the east, now at 100 west. The Ecuador is over here at 80, so what do we got? Another couple of weeks, and it'll make its way in there. We'll see what, and then the real suspense is, well, what happens after that? We have no illusions whatsoever that this is like part of some developing El Nino trend. Definitely not. You can see the Kelvin waves have been getting progressively weaker. This one's a little bit stronger, but there's just, when you get, you don't have Kelvin waves all the time. They basically come in cycles, and then things kind of go quiet, or they're very weak if they do happen. And that's where we are. We've come out of a El Nino of some kind. Last year was a weak El Nino, and now we're transitioning to, they call it ENSO neutral, though it smells very much like we're moving even beyond that into some sort of weak La Nina pattern. In fact, let's go take a look at some more data to see if that is the case. So here we are, sea surface temperature anomalies, differences in normal for this time of the year. Here is Peru, Chile down here, Galapagos right there, Central America, you get the drill, the equator right there. Okay, blues are cooler than normal. So here is the last of that little cool pool being squeezed to the surface by a Kelvin wave somewhere, what did we say? It was like down around, somewhere leading edge was down around here, squeezing the last of the cool water out. But we also know there's stronger than normal easterly anomalies here. We also know the inactive phase of the MJO is setting up. So we don't really expect these cool anomalies to disappear at all. They're probably going to continue for the foreseeable future. There is a Kelvin wave pushing its way off to the east. My bet is it's not going to make it to the Galapagos. It'll stall. You can see pieces of it trying to bleed to the surface, but out in here is probably, its strongest signal right now. Nothing particularly strong. If you were in El Nino, you want to see a big triangle of warming right in here. We're not seeing that. We're seeing cool water here. Though the official, so this is called the Nino 1.2 region right here. It would be cooler than normal. The official El Nino monitoring region is the Nino 3.4 region out here from 120 west, 5 degrees north and south of the equator out to 170. So a little bit off the image here. And you see, yeah, it's warmer out there. But in here, not so much. And a lot of this, south of California at 120 west, it's the water temperatures down in here that dictate a lot of what the precipitation will be for the winter. And if you got cooler temperatures here, cooler temperatures do not support evaporation. They don't support condensation. They support high pressure buildup north of the equator. If it was much warmer than normal here, then you would see lots of storms, the jet stream plowing into California. Maybe late. I mean, this is still a little bit early in the year. We're not even to Halloween yet. But we're trying to tease out a sense of what the next 3 to 4 to 5 months are going to do. And right now, we're seeing nothing that suggests like some strong jet stream pattern in the East Pacific. If anything, it'll be limited out to the North Dateline region, which is kind of what we're seeing right now. We suspect that pattern will continue. That's not to say there won't be precipitation in California, and there won't be swells in the Gulf of Alaska, but our sense is they'll probably be fewer and far between than normal and not as strong as normal when they do happen. Next up, here's the trend for the past 7 days. You see kind of a mixed pattern, a little bit of cooling. Oh, so here's the equator right here, right? Dateline right there. Central America, South America, you get it. Cool anomalies, just a small little area off of the Galapagos and Ecuador. Nothing wholesale in terms of large coverage. Warm anomalies, very weak warm anomalies have been occurring the past week west of there. But again, nothing really strong. A generalized warming trend off of Chile, which is kind of better, but still nothing real strong. I mean, just kind of a mixed, semi-neutral pattern. And then, not the trend, but actual sea surface temperatures anomaly for the entire Pacific Ocean. Pretty much what we've been seeing all along. cool anomalies off of Peru and Chile, warming on the equator, not El Nino warming, but certainly not La Nina either. Just sort of this neutral, slightly biased warm, but I don't know if it really is. I mean, it's kind of, let's give it another month before we really know. We do know there's a Kelvin wave there, and there's some potential for some warming here, but no El Nino warming. But the good news is no clear signs of La Nina either, though from an MJO perspective, an atmosphere perspective, and the jet stream, it smells more like La Nina than El Nino. Sea surface temperature index for the Nino 1.2 region, that area right up there along the Galapagos and Ecuador and Peru. You can see the trend. If you draw a line through this, it's pretty much down. This is dead even here. Today's value, 1.622 degrees below normal. That's pretty cool, and you can see it's been cycling, hovering around there. I mean, that's, if this were happening in the Nino 3.4 region, it would be clearly a sign of La Nina. It's not doing that, but we're not completely discounting this either. And then so here's the real weirdness about all this. Then you go to the Nino 3.4 area, the official El Nino monitoring region, and yeah, we were negative about 0.6 of a degree back in mid-September, but we've been slowly working our way up. We're at plus 0.264. I mean, that's, you got to be up at half a degree for 5 months before you can be El Nino. So we're basically dead neutral, biased, slightly warm, and that only has been for the past month. But the overall trend probably is hovering right around neutral. So certainly not warmer than normal, but not colder than normal. A real mixed bag. All right, so we've looked at the subsurface profile, and we see, some warming, a Kelvin wave coming across. We've looked at the surface, and we've seen kind of a mixed bag. Let's look at the atmosphere above the equator and see if we can, figure out what's going on there. All right, so we look at the Southern Oscillation Index. Okay, difference in pressure between Darwin, Australia, and Tahiti. When the index is negative, that means that there's lower pressure in Tahiti, and that means El Nino. When it's reversed, when the index is positive, that means La Nina. All right, and likewise, on the short term, if it's positive, that's the inactive phase of the MJO. If it's negative, that's the active phase of the MJO. All right, daily contribution today, 1.42. Basically as neutral as you can get, doing nothing. Past couple of days, it was negative, but then the days before that, it was positive, and the days before that, it was negative. So really, no rhyme or reason in the past. We'll go back a month. Really, it's just kind of all over the place. 30-day average takes some of the noise out of it. It's today's value minus 3.98. So yeah, just below average. Weekly bias towards the active phase of the MJO. But notice, it was even half a month ago, it was at minus 0.8.7. Now we're at minus 3.98. And prior to that, we were down at a month ago, we were down at minus 14. We've lost a lot of ground. Again, moving rapidly towards ENSO neutral. The 90-day average, minus 6.59. Where were we a month ago? Minus 7.44. Not as bad, but I suspect a month from now, this is going to be up at like minus 3 or something like that. So what's the meaning of all this? Well, clearly it's showing we're not in La Nina, but we're certainly not in El Nino either. In fact, let's go to look at a graph. So the 30-day SOI average, here's where we are today, minus 0.5 or 0.3, depending on, there's a little bit of variation depending on who's calculating the numbers. But the trend, now this is the really interesting part. So in January, it looked like we were in La Nina, but we weren't. And the trend, if you draw a trend line through this, it's heading negative and not going positive, which almost sort of smells, well, if you really want to be in El Nino, you'd be down at minus 15 or something. We're nowhere near that, but we're still biased in favor of El Nino. And remember that the low pressure bias that's hanging out on the dateline? Yeah, this thing here, remember that? Well, the real data seems to support that there is some sort of a weak negative bias in the Pacific Ocean from an SOI perspective, weakly favoring El Nino. Nothing strong, but it appears to be there. The interesting part is the MJO doesn't really seem to be paying any attention to it. The jet stream doesn't seem to be paying attention to it. And the actual storm track is certainly not paying attention to it. So at best, we'd probably say it's a wash. I mean, all the different indexes are kind of skewed, some towards La Nina, some towards El Nino, none of them strongly. So we're just flopping around somewhere in the middle here. So what is the forecast for sea surface temperatures in the Nino 3.4 region for the coming months? Well, here's where we are today. Supposedly, we're half a degree above normal. We're not really. We're probably a quarter of a degree above normal. The forecast per the CFS version 2 model says temperatures holding about like this the whole way through winter into spring and then falling to neutral sometime next summer. So this is actually positive. This says, hey, we're not going into La Nina. I'll take it any day of the week. It also, if this plays out, sort of suggests that, well, we probably should have moved to La Nina, but we're not. We're staying weekly warm. That is possibly a sign that we are, again, in the warm phase of the PDO. Pacific Decadal Oscillation, a 20 to 30-year oscillation. We've been in the cold phase of it. The cold phase is like a La Nina, like a 20-year La Nina. We've been in it since January of 98, and the thought is in 2014 we started to pull out of that, and all this data sort of seems that there is a bias in favor of warming in the Pacific. And we'll see if even half of this, we only got a quarter of a degree above normal this winter. I would say that still puts us probably in the warm phase of the PDO. So for the immediate future, there's surf on the way. Swell coming for Hawaii and the U.S. West Coast from a gale that was over the North Dateline region. Past that, probably a weaker pattern, nothing from the southern hemi, and if anything, high pressure locking down the East Pacific, not even wind swell, so get whatever swell you can, make the most of it. Medium-term forecast, we're in the inactive phase of the MJO, no clear signs that we're going to be pulling out of it until we get into maybe the mid-November-ish time frame, something like that. And then an improving pattern for late November all the way through into Christmas with the active phase of the MJO in control. Beyond that, long-term outlook, not La Nina, supposedly, but not El Nino either, but weakly biased warm. We'll just have to see if we are in the PDO. Maybe we'll eke out a semi-decent winter, but based on what's happening right now, that's not the case. Precipitation outlook, not looking good either. There is no signs of warming in the equatorial Pacific, in the East Equatorial Pacific, and that's what we'd want to see to get a really healthy winter precip outlook, and that doesn't look like it's going to happen either. Probably a drier than normal winter for California. So that's it for this week. If you like the video, be sure to hit the like button down below. If you want to get notifications when you do this, hit the, there we go, right there. Hit the down below, the subscribe button. I think there's a little bell next to it. Click on that. You'll get an email notification when we update these videos. But otherwise, we also put notifications on our site. Visit stormsurf.com. Just about all the data you've seen in this presentation comes from Stormsurf. And other than that, we're going to do this again next week, same time, same channel. Thanks for watching.